Hello again. This is the first section of our lecture, Respiratory System Development. In this section, we'll talk about the lung buds and how does its formation takes place. We'll also see the concept of laterality and how it affects the lung buds. Now let's get into it. First of all, so there's a figure in this slide. This is the cranial end of the embryo. This is the caudal end. This is the dorsal part. This is the ventral part. So you can here see this is the cardiac bulge. In this portion, the adult heart would be formed. This is the respiratory diverticulum. This is the foregut and the stomach. So the respiratory diverticulum is being developed from the ventral wall of the foregut. All right, this is what is being seen in the figure. Let's see what happens. So first of all, the respiratory system is endodermal in origin, endoderm being the third innermost layer of the embryo in a trilaminar stage embryo, and the respiratory system is endodermal in origin. It develops from the respiratory diverticulum, which was formed from the ventral wall. This is the ventral wall, this is the dorsal wall. Again, dorsal wall is towards the back. This is the back, and ventral wall is towards the front. This is the front. For the concept, for the purpose of understanding, this is the dorsal side and this is the ventral side. All right, dorsal side is always towards the vertebral column and ventral side is towards the abdominal wall. So this is a 4th week embryo in which the respiratory bud develops, and it appears as an outgrowth on the ventral wall of the foregut. I've explained this earlier. So now let's see what is happening in this figure. So this is the gut tube. This is the gut tube, and this is the respiratory diverticulum that is being formed from the ventral wall of it. How does it form? There is increase in the retinoic acid production by the adjacent mesoderm. So the mesoderm in the area surrounding the respiratory diverticulum, it produces an excess of retinoic acid. So what does an excess of retinoic acid do? It causes upregulation of the transcription factor TBX4. TBX4 is the name of transcription factor. It's not an acronym. It has to be remembered as such. So TBX4 is expressed within the endoderm. Respiratory system was endodermal in origin. TBX4 is being expressed within the endoderm of the gut tube at the site of respiratory diverticulum. So the mesoderm causes increase in production of the retinoic acid. The retinoic acid acts on the transcription factor TBX4, which is being expressed in the endoderm of the respiratory diverticulum. So what happens then? The interaction between these two agents induces the formation of bud. This bud is formed, this in blue is formed, and continued growth and differentiation of the lungs. So what do we need? We need retinoic acid. Retinoic acid needs to be formed from the mesoderm, which is surrounding the endoderm, from where the respiratory diverticulum will be formed. This retinoic acid would cause an upregulation of the transcription factor TBX4. This TBX4 would act on the endoderm to produce the respiratory diverticulum, and it would also help in the differentiation and development of the future lung. So now we have a figure again. This is the beginning of the 4th week here. This is the gut tube in pink, and this is the respiratory diverticulum being formed. All right. Then as the time progresses, this respiratory diverticulum divides into two. These are the tracheal buds. These tracheal buds would give rise to bronchi. This is the further development. And with now the bronchial buds are being formed, and with further development, a mature lung would be formed. So the epithelium of the internal lining of larynx, the upper portion of the respiratory tube is larynx, the trachea, the central portion of the respiratory tube, and bronchi. These are the bronchi. They are endodermal in origin. We talked about it. Respiratory system in almost its entirety is endodermal in origin. However, the cartilaginous, the muscular, and the connective tissue components of the trachea and the lungs are derived from the splanchnic mesoderm that surrounds the foregut. Alright, this is the splanchnic mesoderm, this in brown. This is surrounding the foregut, and this is responsible for the production of cartilage, the muscle, and the connective tissue. So the lining is endodermal in origin, and the cartilage, the connective tissue, and the muscular component is splanchnic mesodermal in origin. And where does this splanchnic mesoderm comes from? It lies along the foregut, and here in the figure you can see this in brown is the splanchnic mesoderm. It is contributing the muscular, the cartilaginous, as well as the connective tissue components to the developing lung bud. Now, we're still talking about the formation of lung buds, but now we'll see how a partition develops between the developing esophagus and the developing trachea. We'll see how these two tubes divide. The division of this tube is very important because both of them carry out different functions which are entirely different from each other. So let's see how that happens. So initially, the lung bud is an open communication with the foregut. Here, in this figure, you can see this is the foregut in orange, this is the foregut in orange, and this in blue is the tracheoesophageal bud. So here we can see this is the tracheal bud, and here we can see it's an open communication between the foregut as well as the trachea. So then the diverticulum expands caudally. This is the caudal expansion of the diverticulum. This is the caudal expansion. Caudal is towards the feet, cranial is towards the head. The diverticulum tends to expand, and these are the folds. The tracheoesophageal folds are formed which tend to fuse with each other. We'll see how that happens. Two longitudinal ridges, the tracheoesophageal ridges, are formed which separate it from the foregut. These tracheoesophageal ridges or tracheoesophageal folds, they come into a position with each other and they fuse together, the fusing of which results in the formation of tracheal septum. So these ridges fuse with each other and they form the tracheal septum. This tracheal septum separates the esophagus as well as the trachea. So what happens? Recapping it, we had a common the tracheal, the foregut tube. The foregut tube, from where there was a respiratory diverticulum. The respiratory diverticulum was in open communication with the trachea. After that, there was caudal expansion of this respiratory diverticulum. Caudal expansion caused the formation of two longitudinal ridges or folds. These folds were called the tracheoesophageal folds or tracheoesophageal ridges. With development, these tracheoesophageal ridges or tracheoesophageal folds came close. This is them coming close, and they caused apposition with each other. They underwent apposition with each other. They formed a junction, a tight bond between them. This results in the formation of the tracheoesophageal septum. So the foregut now divides into a dorsal portion, which is the esophagus. This is the dorsal portion, the esophagus, and a ventral portion, which is the trachea and the developing lung buds. So in this section, we saw how a lung bud develops from a developing foregut. The important thing to remember was that the lung bud develops from the ventral foregut in a fourth week embryo. After its development requires retinoic acid to be secreted from the surrounding mesoderm. This retinoic acid acts on the endoderm, the endoderm, and it causes the formation of this lung bud and also helps in the maturation. How does it do that? With the help of transcription factor TBX4. After its formation, there is caudal expansion of the lung bud. Caudal expansion of the lung bud causes the formation of two longitudinal ridges or tracheoesophageal folds. These tracheoesophageal folds come in apposition with each other to form the tracheoesophageal septum. The formation of tracheoesophageal septum results in the division of foregut into a dorsal portion, which is the esophagus, and a ventral portion, which is trachea and the lung buds. So in this section, we talked about how the lung bud is formed from the ventral portion of the foregut. This is happening in a fourth week embryo. The ventral portion of the foregut gives rise to a respiratory diverticulum. This respiratory diverticulum is formed under the influence of retinoic acid, which is being secreted by the mesoderm that surrounds this respiratory diverticulum. This retinoic acid now acts on TBX4, which is a transcription factor being expressed in the endoderm. Now this transcription factor, this helps in the formation of the respiratory diverticulum as well as the maturation of the lung bud. We also saw how the trachea and the esophagus divide. We saw with the caudal expansion of the tracheal bud, there was formation of tracheo-esophageal folds which came in apposition with each other to form the tracheo-esophageal septum. We then saw how the dorsal portion of the foregut became the gut, the esophagus, and the ventral portion became the trachea. I hope you understood it. Keep watching sqadia.com.